Today we're going to talk about the chi-square distribution. So it is similar to your z-table or your t-table, or you have to look it up in the back of the book to put it in a formula. This one is used for your confidence intervals of a variance and standard deviation. So instead of looking at the mean or your probabilities, we're now doing variance and standard deviation. You're still going to use your degrees of freedom, so where you take your sample size and subtract 1, just like you did with the t-score. We're now going to be looking at table G. So taking a look at what your chi-square distribution is, this one does not look so much like your normal distribution. It is leaned more towards the left side of the graph and says all the values are greater than or equal to 0. It again is a family of curves like your T curve. Let's see. And it's positively skewed, so it's over again on this side. But of course, as your degrees of freedom or your sample size gets larger and larger, notice it is getting more and more to look like your normal curve. So what we're going to do to look up things in a table, we're going to have something called a chi-squared right and a chi-squared left. So to find your chi-squared right, you're going to take 1 minus your percent, and you're going to divide that by 2. You're going to look that up in the table. Of course, using your degrees of freedom. Your chi-squared left, you're going to take 1 minus this, which is called your alpha over 2. So when they give you alpha, that is whatever this number is. And you're going to look it up in the table. So what the table looks like is this. This is from the back of your book, your table G, as you see. Here's your degrees of freedom on the left, and then your alphas on top. So let's take a look and see how we're going to read this table. So we're going to find the value of chi-squared left and chi-squared right. And notice it tells me alpha. So it's telling us alpha. It is not telling us the actual percent. So what we have to do first to find the chi-squared right, so we're always going to start with chi-squared right. This is already the 1 minus, so we're going to take the 0.05 and we're going to divide that by 2, which gives me 0.025. We're going to go over to this table. And, it did say that your sample size was 15, so we have to subtract 1 from that. And we're looking at the 0.025. So if we look at it, the 0.025 is here. We want to do our degrees of freedom of 14, since we subtracted 1 from the sample size. And we go over here, and our chi-squared would be 26.119. So 26.119. Now, for your chi-squared left, you're going to take this 0.025, and you're going to do 1 minus 0.025, which gives us the decimal of 0.975. And we're going to look that up over in the table here. Again, degrees of freedom of 14, and then we see up at the top 0.975, so we're going to go down at 14, and so it's 5.629. So my chi-squared left is 5.629, and that's how you read the table. So now what we're going to do is we're going to look at the problem more like what we would have in our word problems, where it actually tells us the percentage. So to figure out our chi-squared right, you got to do 1 minus the 90% as a decimal, which would be 0.9. That's going to give us 0.1. We're going to divide that by 2, which gives us 0.05. The degrees of freedom will be 24 because our sample size is 25. So we're going to go over 24 and the 0.05 down to the 24, which would give us our chi-squared right at 36.415. So chi squared right is your 36.415. Now for your chi squared left, again, you're going to take your 1 minus 0.05, and you get 0.95. So again, go over to the table. Looking at the degrees of freedom of 24 at the 0.95, so it would be 13.848. And that's how you define your chi squared.